let's take a look at that. Oh, actually, I want to use mine. All right. Now, I won't spend, I'm not going to dwell too much on some of this stuff. I feel like, again, you guys have heard this stuff before, but I just want to make sure we're all good on the same page here and stuff like that. Okay. So, adding or subtracting polynomials, right? The question here is, how do you add or subtract two polynomials, and what type of expression is the result? So, just to refresh your memory, a polynomial function of degree n has a standard form, and then p of x equals, and then you can see here's a coefficient times x to the n, plus then another coefficient times x to like the n minus 1, so like a lower power, so on and so forth, all the way down to like your constant term, a sub 0 there. Okay? So, that, when you add all these things together, is called a polynomial, and then each individual term of a polynomial is called a monomial, right? So mono meaning one. So each one of these, so that's a monomial, on down, that's a monomial, right? That's a monomial, that's a monomial. But when you add them together, right, if you add two monomials together, it's a binomial. If you have three monomials together, it's a trinomial. And then there might be other names and stuff like that, but eventually you just call them polynomials once you add so many, right? Because poly means many, right? Like a polygon, many-sided shape. A polynomial has many nomials, many terms, okay? So, and again, letter A, we'll just scoot through this here pretty quick here, but we'll identify the monomials here. So, for example, A, x cubed, is that a monomial? Is x cubed considered just a monomial? Yes, it is. It's a single term, cubed, okay? So x cubed is a monomial. What about this? Y plus 3y squared minus 5y cubed plus 10. Is this whole thing considered a monomial? No, it's a polynomial, right. So you can put that, y plus 3y squared minus 5y cubed plus 10. Okay. What about a squared b c to the 12th? Yes, that would be a monomial. Okay, it's all multiplication there. So a squared b c to the 12th. Again, we're on page 271. 271 there, folks. And then what about the number 76? Monomial, that's right. Okay. The degree of this monomial, x cubed, what would we say the degree of this one is? It's a 3, yeah, the degree is 3. What about the degree of a squared b c to the 12th? So, that's a good question. Yes, it's the 12th power, I guess. Well, let's see. It's the degree of the monomial term with the greatest degree. So I'm not sure if we should say this is 12, or if we should say it's 15. If you take the 2, the b has a 1, and that c is 12. I don't say it should be like 15. I'll have to look that up. Is it 15? I'm not sure if it's. I think you do need to add them all together. I think so. I'm not sure though. I'll take a look at that though. 15/12. We'll see here. All right, and then 76. What's the degree of that? Not 1. Yeah, nothing or 0. The degree would be 0 here, because you can imagine if you put an x to the 0, that would be the same thing as just 76, right? X to the 0 is 1. So I guess I should write this here. Okay, 76x to the 0 is equal to 76. A 1 would indicate it would be 76x. So, okay. Letter C says, to identify the terms of the polynomial y plus 3y squared minus 5y cubed plus 10. So what are the terms of this polynomial? Or what are the monomials inside this polynomial? Y, 3y squared. Yeah, I'm going to say it's a negative 5y because it's got the minus in front of it, but that's fine, yep. And then 10, yep. Okay, and then identify the coefficient of each term. So what's the coefficient of the y term? Right, there's not one written, so we put a 1 there, right? What's the coefficient of 3y squared? 3, and then negative 5y cubed? Negative 5. And what's the coefficient of 10? It's 10, yeah, it's just 10. Yeah. Okay, now what's the degree of each term? What's the degree of just y? 1. What's the degree of 3y squared? 2. Negative 5y cubed? 1, 2, 3. And then what's the last one? 0. Yeah. And now it says to write the polynomial in standard form. So when it says to write this polynomial here in standard form, what does that mean to do? Descending order by degree or power. So what should be the very first term that we actually write then? Negative 5y cubed, very good. And then plus 3y squared, and then plus y, and then the 10. Very good. And then letter G, what is the leading coefficient of this polynomial then? Bless you. Negative 5, yeah, it's just the number in front of the highest powered term, negative 5. Okay? We would still, even if it was written in this order, we would still say that negative 5 is the lead coefficient because it is the coefficient of the highest powered term. Okay? The lead part of lead coefficient is really the lead when it's in descending order or standard form. Okay? So you want to make sure that's, understood there. We wouldn't ever say that 1 is the lead coefficient here. That's just not right. It's the lead coefficient is when you put this polynomial in standard form and then what's the highest powered term. Okay? So, we'll talk real briefly. Actually, no, we're just going to jump down because this is almost like too much, I think. We'll just jump down here. So next page, page 272. Let's just take a look at like one of these together and then I'll have you try the next one. So we'll do 3 here together and then I'll have you guys try number 4. All right? Because really I feel like we should be okay with this. Okay? So you'll notice here that we are adding the polynomials together here. So we have this polynomial and this polynomial. Notice they are not in standard form, or at least the first one. That's not in standard form, right? So anywho, so let's go to Patrick. Patrick, to add this polynomial to this polynomial, what can we combine together? How do we go about adding those two polynomials together? Okay. Perfect. Yes, they are like terms. So we're going to put those two together. So negative 2 plus 11, 9. Oops, not x squared, Mr. Widmeyer, x cubed. Okay. So we kind of took care of those. I like to cross those out to like not confuse myself. What else can go together here, Patrick?
8x squared.
And what happens to those? Yeah, they're just gone, right? Positive and negative, they're opposites. They're gone. You could put a plus 0x squared if you really wanted to, but... Okay, what else goes together? 4 and 12. Okay, so that's going to make what? 16. Okay. What else goes together? Jake says nothing. What do you say, Patrick? Nothing. So then what do we do with this 17x to the 4th and this minus 9x to the 7th? So we just leave them there? What should we do? We're bringing them down because there's like we didn't do anything with them, but they're still there. They're still part of the problem. So if you'll permit me, I'm going to put that 17x to the 4th in front, and I'm going to put the minus 9x to the 7th out at the end, and then technically I am done. Okay, but since we want to be, hold ourselves to a little bit of a higher standard here, I'm going to put it in standard form. So like highest power first, it'll be negative 9x to the 7th, then 17x to the 4th, then 9x cubed, then the 16. Would I take points off if you left this as your final answer? No. Unless the directions specify, put it in standard form or put it in descending order, whatever it might be. But if the directions just say add the polynomials, I'm fine with this. Or any other combination that's correct. But again, we want to hold ourselves to a bit of a higher standard here, so we're going to try and strive for putting things in descending order too. Okay? So go ahead, take a minute or two and try number 4, please. Okay. Take a minute or two, try number 4, please. Yes, sir.
I didn't do this, but I was watching you.
Okay, that's fine.
There isn't anything to the first power at that number.
I see what you're saying.
Anything to the 0 power at 1.
Correct. So, I see what you're saying. Let me see what I real quick. So we have like x cubed. Okay. So like x cubed, right? The degree of this is 3. Yeah. Right. The degree of this 2. Right. Okay. So then the question is, all right. This So you determine the power of this because the x is being raised to the third power.
Yeah.
Here, it's x to the 2. But technically, isn't 2 being raised to the 1?
Yeah.
But we still say the degree is 2 because we don't really care about the power of the number. It's more the power of the exponent of the variable.
Of the x.
So then here, there is no x.
Okay, so that's why it's 0.
It's x to the 0. Right, you could put an x to the 0 there and it's still the same thing. Yeah, no problem. Great question. Okay. So you're going to give this one a shot. Sean, if you don't mind, so we're going to try this one. It's number 4. Okay, do you need a calculator? Yeah, just try number 4. Let's put those two. So Greg, what did you end up getting here? Did you get to finish number 4?
Yeah.
Okay, so let's, what'd you get for your answers here?
I got 3x to the 11th power plus x to the 6th power plus 4x to the 4th power minus 9x plus 7.
Okay, wonderful. So the only like terms that we had here is to combine were the negative 8 and the negative 1x. And that makes the negative 9x there, very good. And then 17. One thing I want to point out here, right, because eventually we're going to get into multiplication, okay? Notice that when we combine terms here, right, when Greg combined the negative 8 and the negative 1x, right, he knew they went together, he did not say it was negative 9x squared, right? It's not x times x here. We're combining like terms, right? Now, this doesn't make a complete sense here, but if you had negative 8 oranges and you added negative 1 oranges, you wouldn't have negative 9 oranges squared. You just have negative 9 oranges, which I know it's weird to talk about having negative 9 of something, but the point is when you combine like terms, the variables aren't changing. You're just putting them together. You're grouping them together, right? A negative 8x plus a negative 1x makes just negative 9x. The variable itself does not change. It's just how many of those variables you combine together, okay? The variables don't change, though. When you multiply, it's a different kind of idea. We'll get to that here a little bit later. All right. So of course we also want to be able to subtract polynomials too. So we're gonna skip all this mess here because I think you guys can get it. We'll just do one example together and then you'll have you guys try one. So let's look at number 6. My recommendation is to forget about doing subtraction and just change any subtraction problem to adding the opposite, right? So here we have this minus. Since this minus is in front of parentheses, we can just distribute the minus through the parentheses there. So I'm going to make this plus, and then that minus, the negative 9x to the 4th becomes now positive 9x to the 4th. The positive 6x squared becomes plus negative 6x squared, and the minus 31 becomes plus 31. Okay? Don't make it harder than you need to, right? And so then Andrew, with me changing this now from subtraction to addition and making these all things opposite, all right, what can we combine together? What goes together now? Or what will be our answer when we now add these things together?
You can cancel out x to the 4th.
Okay, the 9x to the 4th is canceled. Great.
You can just finalize x to the 7th x squared.
Okay, so that's going to be 23x to the 7th, you're saying, and then bring down that plus negative 6x squared or minus 6x squared, whatever you want to write there. Okay, anything else?
It would be 32.
Plus 32. Very good. Okay, and so that takes care of it, not only putting it in order, but also, and power, but also then combining all your like terms. So that's as far as we can go. Okay, so go ahead, take 30 seconds and try number 7, please. Okay, go ahead. Yep. Try number 7, please, real quick. And then if we feel like we got a handle for that, then we can move on to multiplying. Okay, so let's see here. So Josh, what can we do here? Okay, so they do go together, that's right, but we do have subtraction here. Did you change the subtraction to addition? Okay, so let's do that. So I'm going to make it minus, and then that becomes plus, and then a negative there. Okay, so I'll do that first. And then, yeah, the negative 8 plus the positive 2, that gives us a negative 6x to the 5th, right? Okay, so we took care of that and that. What else now? Okay. So yeah, 20, and that's going to be a negative 9, right? Because we had that minus here, it was plus a positive 9, but then when we change that minus to a plus, it becomes a negative 9. So then 20 minus 9 is 11 x squared, so we took care of those two. And then what now? Any other like terms to combine? Nope. So we'll just bring the other two down. Yeah, don't forget about those last two. And then, of course, since it's not in descending order, we got to flip these two around. So now negative 6x to the 5th is the highest term, and 7x cubed, then 11x squared, and then 13x. Okay, and there it is. Okay. There's a couple strategies to doing this. Okay, one option that you have, if you don't want to if you want to get it in order right at the start, is you can kind of start and just scan your problem for the highest powered terms. And so here, for example, we could have started like Josh did with adding together the negative 8 and the positive 2 to get that negative 6. And then we could have kept scanning for the next highest powered term, which is the cube, or sorry, yeah, the cube, so 7x cubed. And then we could have just seen, okay, well, there's no other cube terms, so we just bring that 7x cubed down. Then we can look for the next highest power term, which is the square. We have 20x squared and the negative 9x squared, so we have 11x squared. And the next highest power term is 13x, and then we're done, right? So we can do it that way too. You don't have to like, you can like, if you want to be a little bit more efficient with your time, right, and your work, is you can just start looking for the highest degree and then move your way down until you've run out of terms. And then I'll put it in order for you too. Okay? One other thing I want to mention here just real quick, all right, is that we do have like word problems that we can do with these kind of situations. And look at something like this right here, okay, where it says find the polynomial that models the problem and use it to estimate the quantity. And you look at this thing, and it's like a paragraph. It can be very intimidating, but it's actually a very easy problem to do, okay? Very easy, very doable. But we just have to read and understand what's being asked here. So for letter A, it says the data from the U.S. Census Bureau for 2005 to 2009 shows the number of male students enrolled in high school in the United States can be modeled by the function m, for like, I guess, male, right, of x equals negative 10.4 x to the third plus blah, 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 blah. You get the idea. Where x is the number of years after 2005. And m of x is the number of male students in thousands. Okay. Likewise, the number of female students enrolled in high school in the United States can be modeled by the function f of x equals, and then that polynomial, where x is the number of years after 2005, and f of x is the number of female students in thousands. Estimate the total number of students enrolled in high school in the United States in 2009. So if we have functions that describe the male students and the female students, what can we do with those two polynomials to find the total number of students? Add them together. That's all you got to do. That's literally all it is you just take m of x and you add f of x. Okay, in the equation, t of x is equal to m of x plus f of x. The total is equal to m plus f. That's it. Just add the two polynomials together, combine like terms, and there's your answer. Okay, it's so simple, but it's, it looks complex, intimidating, whatever, with all the reading and stuff like that there. But really, just add them together. That's it. Okay, and we won't do that because they did it for us there. Letter B as well, same kind of idea, but with a little bit twist. So be on your toes here about this one. The data from the U.S. Census Bureau, blah, 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 shows that the total number of overseas travelers visiting New York and Florida can be modeled by the function t of x. So this is the total of New York and Florida right here. Where x is the number of years up to 2000. T of x is the total number of travelers in thousands. The number of overseas travelers that visited New York can be modeled by this function, where x is the number of years up to 2000, and n of x is the number of travelers in thousands. Estimate the total number of overseas travelers to Florida. So now in this case, what should we do with these two functions? Subtract. Take the total, subtract the New York numbers, and then the remaining will be the Florida model, the Florida polynomial. And you can see it here. They have this, it's going to be a minus. And they change the minus to addition and then make these things all opposite here, right? It was negative, positive becomes negative, and then so on and so forth. And you just combine like terms, and you get your answer. Okay? And then it says, estimate the total number of overseas travelers to Florida in 2008. So, once you simplify this, what number do we plug in for x? If we want to estimate the total number of overseas travelers to Florida in 2008, what goes in for x? 8. Because remember that x is the number of years after 2000. So the year 2008, if we're trying to predict that, that's 8 years after 2000. So 8 would go in for x. Okay? That's the idea. All right, so we'll skip through that. I'll assign some problems from that in a second here. But I also want to talk about multiplying polynomials. So if you would please skip to, and we'll skip to page 284. Okay. Alright, so we're at the explain 1 here on page 284. So, a couple things to remember about multiplying now. When we multiply two monomials together, so I'll kind of zoom in on this. When we multiply two monomials together, you'll notice that the coefficients, right, we just multiply. 5 times 6, 30. When you multiply variables together, the same variables, you add their exponents. So this variable has an exponent of 1, and this one has an exponent of 3. So it's going to be 1 plus 3, so 4, right? So x times x cubed is x to the 4th. No big surprises there. Okay, so when we have more, bigger polynomials like this one and this one, okay, negative 2 times 5 gives you the negative 10. X squared times, there's no x here, so it's just x squared. Y to the 4th times y squared becomes y to the 6th, and then z times z, z to the 1 plus 1, or z squared. Okay, so you want to remember those power rules. Oh, here, I understand they're kind of other rules. Remember our exponents and rules and stuff like that too. Okay, now that's multiplying monomials. But when we multiply like binomials here, for example, right? It's like what we did in the warm-up. Okay, you can use FOIL, for example. FOIL does apply here, or you can use the distributive property. You'll notice here, one way we did this is you can take this 1 plus x, and they distribute it to the 2 and to the 3x. You see that? There's 1 plus x times 2, and there's 1 plus x times 3x. I don't know why they switched to x plus 1 there. That's weird. But anyway, 1 plus x times 3x. Okay, you see how they distribute it? And then we can distribute one more time, right? Because there's a 2 in front of parentheses here, so we can distribute one more time. We get 2 times 1, 2 times x, 3 times x, and then 3 times x times 1. And then you multiply and combine like terms. And you get 2 plus 5x plus 3x squared. In other words, that's not in descending order, but that's the idea. Okay, so these two binomials multiplied and give us a trinomial. Okay, same kind of thing applies here for letter A. Okay, if we keep looking here, we can distribute this to the x plus 2. Or sorry, distribute. Yeah. Oh my goodness. Oh, distribute the x and the 2. So they did x times the 1, x times the minus 4x, x times the 2x squared, and then 2 times the 1, 2 times the minus 4x, 2 times the 2x squared. You see that? X times 2x squared, x times the minus 4x, and then x times the 1. And then 2 times the 2x squared, 2 times the negative 4x, and then 2 times the 1. Okay. So essentially, when you're multiplying polynomials, every term here has to multiply with every term here. And it's helpful if you try to come up with some sort of like organizational method. So I always like to take, like the first term here and just do, okay, x times that, x times that, x times that. And the next term, times that, times that, times that. And if there's another term, times that, times that, times that, and so on and so forth. And then multiply and combine like terms. Okay, and so we end up with this. Okay, that gets your answer there. All right. There's another method too to help, and I don't know if this helps or not. Maybe it does. But like you can also take, oops, sorry, let me zoom out some more here. You can multiply these two things, and one way you can do to kind of help yourself organize things, if you kind of write, for example, I'll write like 2 plus x, and I'll make this instead of a minus 7x squared, I'll make it plus negative 7x squared. Plus negative 7x squared, like that. And then down this side, I'm going to write 3x plus negative 4. Like that. And then what you can do is kind of draw like dotted lines, or a line through those plus signs, like that. And it kind of helps to organize your work here. You can see, okay, I got to do 2 times 3x, 6x. I got to do 3x times x, 3x squared. I got to do 3x times the negative 7x squared, negative 21x to the third. I got to do negative 4 times 2, negative 8. I got to do negative 4, and I'll put this line here too. Okay. I got to do negative 4 times x, negative 4x. I got to do negative 4 times negative 7x squared, so 28x squared. And you can see there's all your terms right there. Okay, so you can combine like terms here. The highest power term is negative 21x cubed. Then it goes, we have a 3x squared and a 28x squared, so 31x squared. And then negative 4x and 6x, 2x. And then negative 8. Okay. So there it is. That's another way to do it, using that little, like a table almost or something to help you out. Again, you want to change any negative, any subtractions to add the opposite though, so that way you can just draw the lines through those plus signs and stuff. Okay? So, let's try number 3 together, and then we'll have you guys try number 4. Okay? So, let's see here. Number 3, again, it's 3 plus 2x times the quantity 4 minus 7x plus 5x squared. Again, to do this one, a couple options, right? I like to just take the 3 and just distribute it to all of these terms. So it'll be 3 times 4, 3 times minus 7x, 3 times 5x squared. Okay, so 3 times that, and that. So there's that 3. 4 minus 7x, 5x squared. And then the 2x, so all three of those things too. So it'll be 2x times 4. 2x times negative 7. 2x times 5x squared. So there's all those 2x's. Okay. The trickiest part about this is not necessarily what you need to do, right? It's more like making sure you don't miss something, right? There's lots of little calculations that on their own aren't that bad, but when you put them all together, it can get a little bit confusing because there's so much going on. So guys, 3 times 4, 3 times minus 7x, 3 times 5x squared. So 3 times 4 is 12. 3 times negative 7x is negative 21x. And then 3 times 5x squared is 15x squared. 2x times 4 is 8x. 2x times minus 7, it's a negative 14x. And then 2x times 5x squared, 10x to the third. Okay, and then we have some like terms here. I'm also going to write it in descending order. So 10x cubed is the highest term. There's no other x cubes. And then we have a 15x squared, but no other x squared, so plus 15x squared. And we have a minus 21x, but a plus 8x and a minus 14x. So we have 3 like terms here. So negative 21 plus 8, negative 13, and minus 24, so it's minus 27x. And then the plus 12. And there's our final answer. And of course, if you want to, and you don't need to, I mean, you know, you can also do the little table method if you like. 3 plus 2x down the one way, 4 plus negative 7x plus 5x squared if you like this organization instead. Okay, and then just again, 3 times 4 is 12, 3 times negative 7x is negative 21x, 3 times negative 5x, or plus 5, sorry, 3 times 5x squared is 15x squared. 2x times 4, 8x. 2x times negative 7, negative 14x squared. 2x times negative, or times 5 is 10x to the third. And then you can more easily see your like terms you need to combine here and stuff. I missed an x. Oh, that's supposed to be 14x squared. No, Mr. Wade made a mistake too. 10x cubed, sorry about that guys, plus 1x squared minus, Mr. Wade, 13x, and then plus 12. I apologize, guys. I made a mistake there. The 2x times the negative 7x should be negative 14x squared. I missed the squared there. So anyway, so that's our final answer. Okay. So go ahead, try number 4. Try number 4, and I'll get you guys started on your assignment. Okay. Try number 4 here. See what you can do. Question? Yes. Yeah. Yeah, okay.
How would I do any of that?
Okay, we can talk about that.
I've never used that role. X.
Right, okay. We can talk about that too.
This is like the college of mathematics is what it says.
Right. So I don't so there's also like this too. Are you okay with this kind of stuff? But this is also going to be on the test then?
Yeah.
Okay. So yeah, we can talk about that some more too if you want.
Get all the way up to this college level.
Okay. Yeah, I got you. Yeah. Okay. Yeah, we can talk about it some. Mm-hmm. Yeah. No problem. Say again. Sorry. Yes, if you don't mind, please. Please, 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 yes. We can do that, yes. Yep. We can do that. Let me just put you in for tomorrow.
Yes.
Okay. Some calculators do, but not many.
I keep it as negative. Okay. Yeah, so yeah, it should be negative 18 and positive 4. Yeah.
Okay, so here's what we should end up with right here. Okay, I did it both ways that you could see there, but the both real that answer is there. So negative 4x cubed plus 16x squared plus 51x plus negative 18 minus 18. So the distributive method, and then also the view. Whatever you want to do, as far as organization stuff like that, it's up to you. Okay. Just like the word problems that I showed you guys earlier, you can do multiplication with the polynomial word problems too. For example, here it says Mr. Silva manages a manufacturing plant from 1990 through 2005. The number of units produced in thousands can be modeled by this, or X is the number of years since 1990. The average cost per unit in dollars can be modeled by this, where X is the number of years since 1990. Write a polynomial T of X that can be used to model Mr. Silva's total manufacturing cost for those years. So, if this is the number of products that Mr. Silva's plant makes, and this is the cost to make those products, again, you just multiply, right? The number of products times the cost of products, that'll give you the total cost. And so that's why you're supposed to just do n of x times t of x, or c of x there. But of course that's, we're not going to worry about that right now because it's all decimal and stuff like that. So no big deal there. Okay, so that is our idea here. So let me get you guys your assignment, okay? All right. So on page, it'll be 2 pages because it's 2 sections. I'm not going to sign a whole lot of these because I feel like, well, if you get it, you get it. If you don't, well, there's no sense practicing a million of them. I'm going to have you do numbers 2, 7, 8, and 13. And sorry, that is 276. I apologize. I don't know where I got 261 from. My mistake. Forgiveness, please. Okay, that will be. I want to have you look at 19 as well. And then starting on page 290, number 2. Number 6. And that'll be it. Just 2 and 6 there, I think, actually. We'll stop there. Okay. So that's that. Let me finish this.